All right, higher level DP. So today is what day is today? Today is Wednesday, and it is the 16th of September. I don't actually teach you guys today, but I did have Jaden and Marco come by this morning. Ari, I think you might be off. And this is the question that we were looking at. Okay, we've got a parallelogram with coordinates P, Q, R, and S. R, we don't know the actual coordinates, and the first thing we have to do is find the coordinates of R. Then we have to find the vectors, find the magnitudes of each of these vectors, and then write down the unit vectors in these directions. Okay, so unit vectors is something we haven't covered yet, but we'll do that today. Okay. So first thing I'm going to do is I'm going to draw a little picture. So we did a little bit of this in class, but I do want you to watch this because I'll try and go through it in a bit more detail. So there's my vector P to Q. And then because this is a parallelogram, I'm going to have this vector here, and this one is going to have to be, I'm going to make it S to R. Now the reason I'm making it S to R is just because I can see down here in part B we've got an S to R. So I'll make this S to R. And this can't be involving P or Q obviously because it's a different vector to this one. Well, when I say it's different, it's essentially these two vectors are the same thing, but I can't make this, P to R or Q to S because Q is up here. Hopefully that makes sense. So there's our parallelogram, and I know that P to Q is parallel, and it's also equal to S to R. And what I've also done is I've drawn this in Autograph. So this is a free piece of software which you can play about with. I've got my values, there's P, Q, S, and I still have to put my value of R in, but this is in 3D. You can see where those 3 points are, and I'll put the vectors in shortly, okay, whenever I work out the value of R. Okay, so as Jaden rightly did in class, and Marco, we've got P to Q. Now to work out P to Q, it's essentially O to Q take away O to P. And remember, O to Q is the position vector of Q, and O to P is the position vector of P. So O to Q is 4, negative 1, 3. Subtract 0, 1, 4. So P to Q is 4, negative 2, negative 1. That is P to Q. Now, S to R is equal to this vector because they're the same length. P to Q is the same length as S to R, and they're both going in the same direction. S to R is equal to the vector, so it's R minus S, so X minus minus 1. X minus minus 1 becomes X plus 1. I've got Y minus 5, and then Z minus 6. Okay, so this vector is equal to this vector. And because they're equal, I'm just going to set them equal to each other and work out my value of x, y, and z. So x plus 1 equals 4, y minus 5 equals negative 2, z minus 6 equals negative 1. That tells me that x is equal to 3, y is equal to 3, and z is equal to 5. So that's what x, y, and z are, and that is what I'm after for R. So that is 3, 3, 5. Okay, and I'll put that into Autograph so we can actually just verify that this is a parallelogram. 3, 3, 5. There it is up there. Yeah, that's looking pretty good. And let's put our vectors in. And this software, like I said, is free, so I do recommend I'm going to change this. I do recommend that you download it, play back with it. It is a bit tricky to kind of get used to, really good, really powerful piece of kit. Okay. So there we go, those are our vectors, and we can see, yes, it is a nice looking parallelogram in 3D. And I just orientate this. Okay. And I'm also going to put in the vector R to P, because it says it in part B here. We have to work out R to P. So R to P. So R to P. I need a mouse to do this. It would make it a lot easier. Okay, so there's our vector R to P. Okay. So our next part is to find the vectors PQ, Q to R, S to R, and R to P. So that should be straightforward, just plugging in our values of X, Y, and Z into each of these. Now S to R, actually I'll just do it down here for part B. Now we said S to R is the same as P to Q, so that's just 4, -2, -1. It doesn't actually require that though. We've got P to, sorry, it does want that. We've got P to Q. We worked that out already. That's 4, -2, -1. We need Q to R. Okay, so that's going to be X minus 4. Just check. Yeah, X minus 4. Y plus 1. Z minus 3. And then when I put in my value of X, Y, and Z, I get -1, 4, 2 out. And then the last one we have to do is R to P, which is 0 minus X, 1 minus Y, 4 minus Z. When I substitute my values in, I get -3, -2, -1. So those are my values that I'm after: P to Q, Q to R, S to R, R to P. Okay, so that's just working out these vectors and subbing in our value of X, Y, and Z. Any questions? Give me a shout on that. Right, part C, find the magnitude of each of the vectors in part B. So magnitude just means the length. So all I'm interested in is the length of these vectors, okay? So we'll do S to R first. We'll do the length of this. And to show that it's magnitude, we put it in a little house like this. I'm going to do 4, it's Pythagoras we're going to use for it, plus -2 squared plus -1 squared. And in 3 dimensions, we just put it all in one go. 16 plus 4 is 20, 21, so I get the square root of 21. And that is also equal to S to R is the same as P to Q, the magnitude of P to Q, which is the square root of 21. And we need to do Q to R. Oops. Magnitude, square root of -1 squared plus 4 squared plus 2 squared. That's 16, 20, 21 again. What's going on? I'll come back to that in a second. P to Q, done. P to Q. S to R is the same. Q Q to R, and we need to do R to P. And really, okay, let's do it properly. Our negatives in. You know, when we square these numbers, it gets rid of the negatives, which is why I left them out, but for the sake of doing it properly, we'll put them in. So that's 9 plus 4, 13, so that's 14, square root of 14. Okay, and let's see if we can verify that on autograph. I think we probably can. I go to Q to R, and go to my little box. It's not going to tell me, but maybe if I do it like this. No. There may be a way that it will give us this information, but this is not it. Okay, so we've got S to R and P to Q. S to R, P to Q, the square root of 21. We've also got Q to R, square root of 21, and then P to R, the magnitude of that is the square root of 14. So this is actually it's actually a rhombus because these sides are all the same length. So it's a rhombus technically, which is a parallelogram. Okay, let's do the last part. So unit vectors we haven't covered yet, but I will cover now. So a unit vector is a vector of magnitude 1. Okay, and to find a unit vector, you divide the components of the vector by the magnitude. So what's happening is you've got your vector. So let's look at, we'll start off, we'll do part D and we'll look at the vector P to Q. We said P to Q, the vector of P to Q is 4, -2, -1, okay? And the magnitude of P to Q we worked out is the square root of 21. So its unit vector is going to be, I'll need more room than that. We want the same vector, we want the same direction, but it's only going to have a magnitude of 1. So it's going to be 4 divided by the square root of 21. It's going to be -2 divided by the square root of 21. And it's going to be -1 divided by the square root of 21. Okay, so imagine this vector here. If I do a crude diagram, it's going to be P to Q. It's like that. But our unit vector of P to Q is exactly the same, except it's only unit 1. So that would be the unit vector. Okay, it's only got a length of 1, whereas the whole vector has got a length of the square root of 21, which is why I'm dividing by the square root of 21. Okay, if I was to work out the magnitude of this unit vector, it would be 1. Okay, so the vector itself, the only thing that's changing about it is the magnitude. Okay, the direction stays the same. It's going in the same direction as P to Q, but it's only got a magnitude of 1. And we can do the same with our other vectors. Quite straightforward. So S to R is going to be the same thing. For S to R, the unit vector is going to be 4 over the square root of 21, negative 2 over the square root of 21, negative 1 over the square root of 21, and R to P the unit vector for this is, well, the vector is negative 3, and we're going to divide it by the magnitude of R to P, square root of 14. Sorry, square root of 14. Negative 2 divided by the square root of 14, and negative 1 divided by the square root of 14. P to Q, S to R, R to P, and the last one, Q to R. Our vector was negative 1, 4, 2. But we divide by the magnitude, and the magnitude of Q to R is the square root of 21. And obviously you could write this as well if you want as 1 divided by the square root of 21. It might actually be easier, negative 1, 4, 2. Okay, so you could just take out as a factor. Okay, and that actually shows, because I can do that, that these two vectors, this vector and this vector, are parallel. So they have the same direction, but they may not have the same magnitude. And they don't have the same magnitude because one is 1 and the other one is the square root of 21. Okay, hopefully that makes sense. Give me a shout if you need any help on that. That is unit vectors.